Good morning, students. We have been discussing so far on curvilinear coordinates, in which the transformation takes place from Cartesian coordinates into curvilinear coordinates. Of course, we know we have discussed about Cartesian coordinates. For example, when you take 3 dimension, we are going to represent x, y, z for any Cartesian coordinates. Whereas for curvilinear coordinates, we have been denoting as u1, u2, u3. u1 represents x, u2 denotes y, and u3 goes for z. So we can transform one coordinate system into another coordinate system, Cartesian coordinate system into the curvilinear coordinate system. So very important thing is when two surfaces merge, they merge, and the intersecting line, which is nothing but a curve. So that's called the curvilinear coordinates. And of course, in this class we are going to learn cylindrical coordinates. And of course, we can transform cylindrical coordinates rho, phi, z. So those coordinates into curvilinear coordinates, and vice versa. Similarly, spherical coordinate system, that also can be converted into curvilinear coordinates. So we are going to learn three systems. One is Cartesian, another one is cylindrical, the third one is spherical coordinates. All the three coordinates can be converted into curvilinear coordinates. So in this class, we are going to discuss the cylindrical curvilinear coordinate system. So we are going to transform cylindrical coordinates into curvilinear coordinates, or otherwise curvilinear coordinates into cylindrical coordinate system. So that's why we are going to learn. So in this class, we are going to learn unit vectors in cylindrical coordinate system, and of course we are going to discuss about the gradient of a scalar, divergence of a scalar, curl of a vector, Laplacian in cylindrical coordinate system. So already we learned four systems, the four properties. One is gradient, divergence, curl, Laplacian for the Cartesian coordinate system. And in this class, we are going to learn all the four properties in cylindrical coordinate system. So that's the idea. So this is a cylindrical representation. For any coordinate system, we are going to have rho, phi, z. So three coordinates are rho, phi, z. Suppose we are going to consider a particle P is here. So in a cylinder, we have a particle P is here, and we have x, y, z axis, and we have I, j, k. They are all unit vectors for x, y, z. And this this line represents rho. Rho is nothing but root of x squared plus y squared. Rho, see here we have a rho. This is x squared plus y squared. Now the projection of rho falls on xy plane. So this is your xy plane. See, this is your x coordinate, this is your y coordinate. The projection of this one, projection of rho, see, exactly falls on xy plane. So we have rho here. And this rho, in between this rho and I, the angle between I and rho is nothing but your phi. So rho is there, phi is there. Z coordinate is as usual like this. So we have three coordinates for representing any cylindrical coordinates. One is rho, phi, z. Rho is nothing but root of x squared plus y squared, and your phi, the angle between x axis and rho. Okay, then z is here. So the position of any point in space P having a Cartesian coordinates x, y, z may be expressed in terms of cylindrical polar coordinates rho, phi, z. So we are going to use this. In some other book you may find r, theta, z. Okay, so we are going to follow only rho, phi, z. Some other book you may find r, theta, z to represent the cylindrical coordinates. But we are going to follow the conversion method. We are going to follow rho, phi, z. So this is your Cartesian coordinates, and this will be your cylindrical coordinates. So x equal to rho cos phi, and y equals rho sin phi, z equal to z. Of course, rho is greater than or equal to 0. The angle phi lies between 0 and 2 pi. Z minus into plus infinity, and rho is nothing but root of x squared plus y squared, and of course angle phi is nothing but tan inverse of y by x. As I said earlier, and this rho is a projection. So this rho is a perpendicular distance from the z axis, Phi is the angle between x-axis and the projection. So x-axis and the projection, rho on the xy plane, and z is the same as in the rectangular coordinates. And we know about the position coordinates is given by r equals xi plus yj plus zk in ordinary Cartesian coordinates, we know already. So now I can write this in terms of cylindrical coordinates as r equals, instead of x I can write rho cos phi, instead of y I can write as rho sin pi. Is that as it is? Is that as it is? So this is your position coordinate in cylindrical coordinates. So this is the position coordinates in Cartesian coordinates. This is the position in Cartesian coordinates. This is position in cylindrical coordinates. Now E rho, E phi, E z, they are all unit vectors. Like in Cartesian coordinates, unit vectors are I, J, K. So we have I, J, K, they are all unit vectors. So similarly here, E rho, see here, E rho, E phi, E z, they are all unit vectors in cylindrical coordinates. So E rho is nothing but dr by d rho. So we will have to differentiate with respect to rho, that will give you E rho. Okay, so E rho is equal to, just differentiate with respect to rho, that will give you cos phi I. Differentiating this with respect to rho, that will give you sin phi. There is no rho here, so 0. And E phi is dr by d phi. So when you are going to differentiate this with respect to phi, will give you dr by d phi, which is nothing but E phi. So when you are going to differentiate cos phi, that will give you minus sin phi, so minus rho sin phi. And we are going to differentiate this with respect to phi, will give you rho cos phi j. There is no phi here, so answer is 0. Ez, that will give you dr by dz, which is nothing but, there is no z component, there is no z component, here alone exists, so we have k. Is it okay? Now the unit vector E rho cap equal to E rho divided by mod of E rho. So that's a formula here. So E rho E cap rho, which is equal to E rho. E rho is nothing but cos phi plus I sin phi. Cos phi plus I sin phi. So I have written like this. Mod of E rho is nothing but root of, you have to take square and take the root. Okay, you have to take the components. You have to take the components of I, take the square and take the root. So that will give you your mod. Is it okay? Mod is nothing but, you have to take the square of the component and take the root and add. So, and you have the square is nothing but cos squared phi, add sin squared phi under root, which is nothing but your 1. So we will give you E rho is nothing but this. Similarly, you can have E phi. E phi is nothing but 1 by rho E phi, which is equal to this one divided by root of sin squared plus cos squared, that will give you 1. Okay. E phi is nothing but E phi divided by mod E phi. Mod E phi is nothing but again sin squared plus cos squared, which is nothing but 1. Then E z is nothing but E z divided by mod E z. So which is nothing but k divided by root 1 square. So answer will be k. So we have found out now unit vectors. Okay, very important question is derive the unit vectors for I, j, k. So this is very important. So here it is E rho, E phi, E z. They are all unit vectors of cylindrical coordinates. I, j, k, they are all unit vectors for the Cartesian coordinates. Now look at this one. This I equals, which you are going to derive now, I equals this one, j equal to this expression, and k equal to E z. Now this is the relation between the unit vectors of Cartesian coordinate and the cylindrical coordinates. This is the unit vector of cylindrical coordinates. This is the unit vector of Cartesian coordinate. Okay, now you are going to derive. So this is very, very important question. Okay, so derive the unit vectors of cylindrical coordinates. Now we are going to get this expression. Okay, so now equation 1 we are going to multiply by cos phi. Just multiply this equation by cos phi. So we have E rho Z. So cos phi E cap rho, which is equal to, I am going to multiply this by cos phi. So this becomes cos squared phi I. This becomes sin phi cos phi j. Okay. Now equation 2 multiplied by sin phi. So that will give me sin phi E cap phi, which is equal to You have minus sine squared phi I sin phi cos phi. Now equation 4 minus 5. So I am going to subtract equation 5 from 4. So that will give me, this becomes, you have, this becomes minus, this becomes plus, and this becomes minus. So you have cos phi e rho minus sin phi e phi, which is equal to, and if it is minus, this becomes plus. So we have cos squared plus sin squared, that will give you 1. So you have I alone, and this becomes, the next one becomes, that will get cancelled. So this is sin phi cos phi, this is minus sin phi cos phi, so it will become cancelled. Is it okay? This becomes 0. So we have I equals this one. So this is the same relation. This is the same relation. Similarly, you can get J. Okay, equation 1 multiplied by sin phi. So when you are going to multiply this by sin phi, that will give you sin phi e cap rho, which is equal to sin phi cos phi I sin squared phi j. Equation 2 multiplied by cos phi will give you cos phi e cap phi, which is equal to minus cos phi sin phi plus cos squared phi j. Now you just add these two equations. Add these two equations will give you, this one will get cancelled. Sin square plus cos square will give you 1. So j, this will become j. You are going to add these two, that will give you sin phi e rho plus cos phi e phi, which is equal to j. So this is the expression for your j. This is the expression for your I. Okay. So very important question. And get the expression for I, j and k. Of course, k equals E Z. K equals C. K is nothing but your E Z. Is it okay? It's a very important question. So this is the relation between unit vectors of Cartesian and cylindrical coordinates. Now, the infinitesimal vector displacement dr in the position P is given by. So we are going to have the expression for dr. This is for the length, and this is for the area, and this is for the volume. We are going to have the expression in terms of cylindrical polar coordinates. Okay. So dr is given by partial dr by d rho plus partial dr by d phi plus dr by dz. Okay, but we know already dr by d rho. See, dr by d rho is given as e rho. So instead of this, you can write e rho. This d rho will be as it is like this. Correct. So plus dr by d phi is given as e phi. So this d phi is here. This dz is here. Dr by d is given as Ez. So your dr is given as dr e cap. See here, now you written e cap. Similarly, e phi. Look at here, e phi. There is a relation between e cap, which is equal to e rho. E cap phi equal to 1 by rho e phi. E cap Ez equal to Ez. So instead of this, you can write dr by d rho. Here it is e rho. It becomes e cap. So e cap rho, and e phi. Look at here, we have e phi, which is equal to rho times e cap phi. See, rho times e cap phi, then plus this one. So this is the expression for your length. Okay. Now this is the expression for your area, surface. Area is nothing but length multiplied by length. So dr dot dr. We are going to have a dot product. So dot product will give you dr e cap rho dot e cap rho will give you 1. Is it okay what I am saying? See this dot with the same thing. So e rho dot e rho. So that will give you dr. So d rho whole square dr dot dr. So d rho whole square. This becomes rho square d phi square. This becomes dz square. For the expressions for your volume, we have dv, as we know already about the volume, which is given as a dot b cross c. So you have a, b cross c. So we have three are there. So we have a dot b cross c. So first we will simplify this. B cross c will give you e phi cross ez. E phi cross ez will be e rho. So we have a cyclic coordinates rho phi z, cyclic permutation. So this will be your rho, this will be your phi, this will be your z. Rho phi will give you z. Z rho will give you phi. Is it okay? So e phi cross Ez will give you e rho. The answer will be rho d phi dz. And here also e rho, here also e rho. We are going to have a dot product. So answer will be E rho dot E rho will give you 1. So you have rho, d rho, d phi, dz. So this is your volume element. So expression for your length, expression for your area, surface element, and the last one is volume element in the cylindrical polar coordinates. Now relationship between all the three unit vectors. So we have E rho dot E rho, just now we have looked into E rho dot E rho is nothing but 1. Similarly E phi dot E phi will give you 1. Similarly Ez dot Ez will be 1. Okay, E rho dot E phi, other coordinate, other unit coordinate 0. E phi dot Ez 0. Ez dot E rho becomes 0. And we know that E rho cross E phi, which is equal to Ez. And E phi cross Ez equal to E rho. Ez cross E rho equal to E phi. So any vector in cylindrical coordinate is given by this, any vector. So we have either A vector or a B vector. So A is given as A rho E cap. This is exactly something like in Cartesian coordinates. A is represented as A I vector. Can you remember A1 I vector plus A2 J vector plus A3 K vector. So here also we have A rho E cap rho plus A phi E cap phi plus A z E cap z. So this is the representation of any vector in a cylindrical coordinate. So this is a conclusion. So cylindrical coordinates are rho phi z, and of course we have the unit vectors which is given as E1 cap which is equal to U rho, E2 which is equal to U phi. So this is not theta, this is phi. Okay, it's not theta, this is phi. Rho phi z. And what about your scale factor? Scale factor which we have already learned. So scale factor for cylindrical coordinates will be h1 equal to 1, h2 equal to rho, h3 equal to 1. So you have to learn by heart. Okay, very important, one more question. Scale factor for cylindrical coordinate system 1 rho 1. And your coordinates for x, y, z. So we have for x u1 equal to rho, u2 equal to phi, u3 equal to z. So these are all coordinates. Now our aim is, ultimate aim is to find the expression for gradient, divergence, curl and Laplacian in cylindrical coordinates. And of course the expression for gradient in curvilinear coordinates is this one. So we learnt in the last class. Del phi equal to, can you remember this table which we learnt in the last class? Del phi is given by this expression. Okay, gradient, expression for gradient in curvilinear coordinates given by this. Now for gradient it's given as, this is for all the expression for curvilinear coordinates. Now this one we will have to convert into cylindrical coordinates. Okay, using this we will have to convert. Wherever you find E1 cap, see here E1 cap, you will have to substitute U rho. Wherever you find H1, you will have to substitute 1. Wherever you find H2, you will have to substitute rho. Wherever you find U1, you will have to substitute rho. So this is for cylindrical coordinates and this is for curvilinear coordinates. Wherever you find these elements, you will have to substitute to get all the properties for cylindrical coordinates. Is it okay? So the expression goes like this. So I have written all the three elements here. U1 equal to rho, U2 equal to phi. Here I have written as correctly. See, U1 equal to phi, U3 equal to Z. Where H1 will be 1, H2 equal to rho, H3 equal to 1. Similarly, the unit vectors. So I said wherever you find H1, you have to substitute 1 here. Okay. So del phi is given by this. This is gradient, expression for gradient in curvilinear coordinates, expression for the gradient in cylindrical coordinates. So here 1 by h1, h1 is 1, so here 1. Instead of E1, you have to substitute U cap rho, so U cap rho, d phi by d rho. Okay, this is a scalar function, phi is a scalar function. Similarly 1 by h2 is nothing but your rho, so 1 by rho, and your E2 is nothing but U cap phi, see U cap phi. and uz, you have uz partial d phi by dz. So this is expression for your gradient. This is expression for your divergence. Divergence in curvilinear coordinate system. As usual, you will have to substitute all the elements here. You will get the expression for your divergence in cylindrical coordinates. So we have del dot A, which is equal to 1 divided by h1, h2, h3. That will give you 1 by rho. 1 multiplied by rho multiplied by 1. h1 is 1. h2 is rho. h3 is 1. So you have 1 by rho. So partial d by du1, instead of du1, d rho. See, d by d rho. And here a1, h2, h3. What is h2, h3? h2 is this one. h3 is 1. So we have a1 rho. Is it okay? So here you have h3 equal to 1, h1 also is 1. So da2 by d5. Okay. Similarly, we have d partial d by, instead of u3 you have to substitute z. So d by dz. And you have a3, h1, h2. h is nothing but rho. So we have a3 rho. So this is expression for your divergence, del dot A. The next one is del cross A. Del cross A, this is the expression in curvilinear coordinate system. You substitute to the corresponding elements. So that will give you, so instead of h1 e1 cap, h1 is nothing but 1. Your e1 is nothing but u rho cap. See, u rho cap. And here it is rho. This is nothing but u5. This is nothing but 1. This will be uz. So d by du1. du1 is nothing but rho. So d by d rho. Next one is d by d5. Next one is d by dz. Here it is h1 is nothing but 1. So a1. a2 h2 a2 rho. So last one is nothing but a3. So this is the expression for your curl in cylindrical coordinate system. Here it is Laplacian. The last property is Laplacian. Del squared phi. So this is the expression for your Laplacian in curvilinear coordinate system. So wherever you find h1, you have to substitute 1, h2 as rho, h3 equals 1, and also other elements. So we have del squared phi, which is equal to 1 divided by 1 multiplied by rho multiplied by 1, that will give you 1 by rho. u1 is nothing but rho. So d by d rho. h2 h3 divided by h1. h2 is nothing but rho. Rho multiplied by 1 divided by 1 will give you rho. Your d5, here it is. u1 is nothing but rho. So d5 by d rho. Similarly, other expressions. Okay. So now here, so this can be simplified as this. So we'll have to differentiate with respect to dr will give you this, d5 will give you this, so dz will give you this. Okay. So this is the expression for your Laplacian in cylindrical coordinate system. Okay. Any doubts, friends?